I'm going to finish this series of clips by talking about a couple of challenges that arise when we try to estimate elasticities of demand from real-world data. Understanding these challenges will help you to think about whether or not it's a good idea to trust any given estimate of elasticity that you find or compute yourself. Of these two challenges, one is relatively easy to understand, which is that things other than price can affect quantity demanded. Let me give you an example of what I mean. Suppose I'm looking at the market for ice cream, and I go out on a hot day and I observe the price and quantity at some point P0, Q0, based on some underlying demand curve that is the demand for ice cream on a hot day. Then suppose I come along and make another observation at a higher price and lower quantity that by chance happens to be observed on a cool day. Well, on a cool day we would expect the demand for ice cream to be shifted in. What that means is that we have two observations of price and quantity that are not actually on the same demand curve. If we didn't take account of that difference in temperature, that inward shift in the demand curve, we would be tempted to draw a line between these two price quantity pairs and say that's the demand for ice cream, and I'm now going to use rise over run to compute its slope. And that, of course, would be very wrong. We need to somehow find a way to take account of the fact that the quantity demanded is a function not only of the price, but also of the temperature. And the way that economists do this is to use regression analysis. Regressing quantity on any given day, let's call it Qi, on some constant term gamma naught, plus the price on that day and the temperature on that day. And then, of course, in a regression model, always add in an error term. In this way, we've controlled for the difference in temperature, which is effectively the same as saying we're going to treat that cool day observation as if it had in fact been taken on a hot day, where this would have been the Q1 that we would have observed. Now, I'm not going to go into greater detail about how this kind of regression analysis is done, but the point is that if you come across this kind of an estimate that has not been addressed with this kind of regression analysis, then you probably shouldn't trust that estimate of slope or elasticity. And indeed, if you have two price quantity pairs and you don't know for sure whether something else might have shifted the demand curve in between the time that those two observations were made, then you need to be somewhat skeptical about your own estimate of the elasticity of the demand curve. The second problem that arises when we are trying to estimate elasticities, which can be much harder to deal with, is that both supply and demand affect price and quantity simultaneously, so that if you see price and quantity at one period of time and then price and quantity at another period of time, there may not only have been a shift in the demand curve, but also a shift in the supply curve in a given market. And it'll be very difficult to tease apart which of those two things is changing the price and quantity. Let me illustrate that with an example that I quite like, which is the market for automobiles. Suppose that there is a series of changes in the price of oil. Now, the price of oil affects demand for cars because when oil is cheap, gasoline is cheap, and when gasoline is cheap, people have a greater demand for cars because they are complements in consumption. At the same time, oil is an input to the production of cars, which means that as the price of oil goes up, the cost of production goes up, which is to say that the supply curve shifts inward. Now, if we had a series of observations of price and quantity for cars taken at different prices of oil from one period of time to another, we might find ourselves with the following complication. Suppose our first price quantity observation happens to be at a time when the price of oil is relatively high, so demand is relatively low and the supply curve is relatively far in. Right? So for example, this might be D naught, the demand curve, at a high price of oil, S naught, supply curve at a high price of oil, and we would observe P naught and Q naught. Then suppose the price of oil goes down, causing the demand curve to shift out to something like this, and causing the supply curve at the same time to also shift out to something like this. Then our next observation of price and quantity would be here, P1, Q1. And then finally, suppose the price of oil goes down again, and we get another outward shift in demand, let's say to here, and another outward shift in supply, say to here, giving us yet another observation of price and quantity. If we were not aware of the way that the price of oil affects price and quantity in the automobile market by shifting both demand and supply simultaneously, we would be tempted to simply connect these three observations of price and quantity with a single line, which we might think of as d hat, and estimate its slope and treat that as if it were a valid estimate of elasticity of demand. Clearly, we would be very far from the true elasticity. The solution to this problem also involves regression analysis, but it's a much more complicated kind of regression analysis, so I'm not going to try to explain it. The main point is this. When you are looking for estimates of elasticity of demand, you need to pay attention to who is doing the research, whether or not they are skilled in these regression techniques and have taken the necessary precautions to be able to address this problem of simultaneous causation. If not, you want to be, again, skeptical of their estimates. That brings us to the end of this series of lectures about how to work with elasticities. After you've taken the associated quiz, you'll work on a series of assignments that will lead you through the steps of applying these tools to the marijuana legalization case. And in addition, you'll see how these tools can be extended to answer more complex questions than simply the change in quantity or consumer surplus when a price goes up. It's a simple set of tools, but it has a lot of application.